So you did 30 pi. What was that?
That was like.
That's the circumference, right? Yep. Why did he do 30, everybody? Yeah, good job. So pi times diameter. So 30 is the diameter. And then he got 94 inches around the tire. Okay, and then the 2640, that's a half mile, so feet in a half mile. Alright, so I'm going to erase that. Why? Why was that wrong?
Because we had to convert it into inches.
Yeah. Okay. So I'm only changing this so that people here around can see it. So you did a good job there. Alright, so this is inches per half mile. And you divided by your 94 inches and got 337 terms. Cool. Alright, so this is a side note. Kind of interesting. Have you ever looked at the side of your tire and seen the numbers, the information? Okay. I'll show you what that means because it does relate to what we're doing. When you order tires or buy tires for your car, you're always going to have some version of these numbers. And when they say it, they just say 225, 75, 16. They kind of ignore the numbers. P stands for passenger vehicle, so this would be like what we drive. Okay? 225, is how wide it is this way. So like the surface of the tire that touches the road in millimeters. That's called the section width. So how wide is your tire? Okay? But it's in millimeters, which is kind of weird, but that's what they measure it in. And then the 75 is called the aspect ratio. It tells you what percentage of that width that height is. So have you ever seen the tires that are like super skinny? Like
Bike tires?
No, like not skinny left and right, but like skinny to the rim. Versus like off-road tires are really fat this way.
You mean like cattle?
No, they're normal. Most of them.
You mean so.
Anyway, that's this number. It's telling you, in this case, the height is 75% of the width. And then what do you think R16 means? What would R be? That's a word we know. Yep. What did you say?
The rims.
It's the rim. And what about the rim?
It's size.
Yeah, but I'm saying, is it the radius or is it the diameter? Yeah. So rim is 16 inches in diameter. Okay? So our problem was probably kind of too big for the car that I picked. It probably should have been a 15-inch diameter, but that's okay. This says the R is for radial, which is a type of tire. I think you could think of it as for the rim. That helps you remember that number is for the diameter. Okay? So guys, these things are what we deal with, right? When we have circles in our life. Can you think of other circles that you deal with? Come on.
Circles
Come on.
on the chairs.
Where? Like the feet?
Yeah.
Okay. True. I guess I don't think of those very often.
Maybe if you're like making something out of wood and you like cut a circle.
Okay. Yeah, like a round table.
Pizza, those eyes.
Pizza.
Camera in there.
Clocks. What'd you say over here?
Camera in there. And the.
Oh, yep.
And then that.
The earth? That's not a circle. The Earth is flat.
I don't care. It's still circular some way.
Well,
If
it's a flat rectangle. Just kidding. All right. Well, so we did circumference with the tire. What else did we learn yesterday?
Area?
Tell me about area. Like, what if I said we need to buy a cover for this tire? No, I can't get the right color on
The space inside of the circle.
this. Yeah. So how would we do the cover? This is gonna be our cover to keep these beautiful tires nice.
Area equals
Are you trying to cover the whole
pi
thing?
radius.
Which is
Pi r squared, right? So 15 squared is 225, so 225 times 3.14. So what is that, like 690-ish? Are you doing it?
706.
No, it's too low. 706. What are the units of area? So that was turns, we had to label, we had feet, we had inches. What are the units of this area for this tire? Good job. So you can write inches squared, or you could put SQIN for square inches. This is the typical way. All right, so that was what we reviewed yesterday. How's that going for you? You feel okay with those formulas? And use. Okay, awesome. So that puts us ready to start some new stuff. So why don't you grab your packet if you don't have it out? Looks like you guys mostly do. This is the very algebraic section of our circles unit. Now, when I say that, we're going to be solving and using algebra throughout the unit, but what I mean is this is you can see we have an XY coordinate graph, so it's that kind of algebra, graphing algebra. So we said yesterday that a circle is all points the same distance from a center point. So all the points on this orange line are the same distance from HK, and that distance is R. So when I say distance, do you remember a formula that we had for distance? That could have been maybe our first note packet, I think.
Well, I'm definitely not.
So let's see if we can put this together. So distance formula, let me write that real quick. That's going to help us with radius. Because if I said how long is radius right now, you see how it's the distance between 2 points on a grid?
Yeah.
Okay. So D equals, do you remember what it was? It has this big old thing in it.
And then it's X.
Okay. I'll give you this next hint. It comes from making a triangle out of those 2 points. It's a right triangle. And we do the Pythagorean theorem.
I think it's plus or minus depending.
No, the signs are the same.
The same,
So how do we find that length, the bottom length?
so it'd be X and X.
Yeah, good.
And
So
and
x2 minus x1 squared, because this is Pythagorean
and then
theorem.
you time,
Right?
and then it's times, correct?
No?
No, plus.
Plus.
And then it'd be the same on the other side.
But with what?
Y.
This is up and down, so that's y. And again, why are these squared?
So if you're times
No. A squared plus b squared, right? Remember Pythagorean theorem. A squared plus b squared, where r in this case is the seed, it's the hypotenuse. Okay? Your r will be the hypotenuse for this. Okay. So that's a quick review of distance formula. So if we did it specifically for this r value, how would this change? Well, it would be x minus h squared plus y minus k squared. H and k is where? I'm not asking for numbers. Like, what would you say that point is? That's the center. Okay? Does everybody see that? Okay. So in algebra, we like to give letters to represent consistent themed pieces. So HK, like for parabolas, HK is where the vertex is. For a circle, HK is where the center is. That's what I mean by that. Everybody follow? Okay. So this is the formula for the radius length. Some point anywhere on the circle. We could have stuck XY down here. That's fine. It doesn't matter because why? What's true about the radius everywhere? It's always the same. Doesn't matter where we draw a radius. It's always the same length. So even if it was here, x minus h squared plus y minus k squared, whole thing square root. I guess I should ask you, why is the square root there? Okay, let's remind you, this is important to understand. If I said find r, and this is a right triangle, here's the Pythagorean theorem. R squared equals a squared plus b squared. We're being more specific to say a and b are those two things. That's all. Okay? But how do you get r by itself? You square root, right? So r is the square root of a squared plus b squared. A is just the distance this way, left and right. And b is the distance up and down to the center. Is this ringing a bell? We've talked about all of this except for just now we're calling it r. That's the only difference. So, but all of the rest of it should ring a bell. Hopefully it does. Okay. All right. We are close to the equation of a circle, but we're not quite there. So let's review this real quick in your notes. Grab that, and we'll say so to find the radius from points, here's that. The formula we just developed. I'll let you get that written and then we'll go put the picture together. Okay, here's what you need to do. First, I want you to put this on an XY coordinate grid. Just because when we're doing equations of circles, we're going to be somewhere in the XY plane. Then you need to label the center with coordinates HK. And then put a point somewhere on your circle. And just call that X, Y. Of course, we need to label that R. Okay? So HK is the center. I suppose we should go on to say and x, y is a point on the circle. Everybody good on where this stuff's coming from? So if I handed you a piece of graph paper and you drew a circle, then we could find the point on the circle, we could find the center, and then we could find the radius, right? I mean, that's one way of doing this. Alright, well, here's the equation of a circle then. Guys, what do I mean by equation of something, by the way? You gotta think back to algebra now. Like, let's say I don't write this. I just want to frame your mind for a moment. Let's say I wanted the equation of that line. What kind of things do we need to know about it to make sure it's this specific line? So what makes an equation of a line? Points do, yep, but that we could use points to get the equation. But once we write the equation, it also defines this line even though we can't see points. So what goes into, I'll start, y equals. What goes into that equation to make a line? Yeah. What does m stand for in mx plus b? Yeah, say it. It's the slope. So it's telling us that this line is this steep rather than like this steep or this steep, right? It's telling us how steep it is. The slope does. What does b tell us? Yeah, it tells us that right there. So now it's not only telling us how steep it is, but it's telling us which point it goes through. So now we have defined that specific line. Okay? So you have done that a ton in your math career. Here's another version. What if I want this specific parabola? What do we need to know? Well, we need to know it's a parabola first, right? So that's going to involve some kind of x squared instead of x. Somehow we need to tell it that it's moved up a little bit off of the x-axis. So that would be like plus 2 maybe. Okay, that shifts it up. Do you see how that equation defines this parabola? Okay, does that make sense? Nod if it makes sense. Okay. This is what we mean by equation of a circle. So how do we define a circle? We've kind of talked about that yesterday. A line, we had to have slope and a place where it crosses the y-axis. A parabola, we had to have a squared so that it's actually a parabola and a y-intercept. How do we define a circle? The set of points what?
Number with distant from certain centered point.
Good. Equidistant is talking about what distance? What's that distance called? If I'm defining a circle, what is the distance that I'm talking about is always the same called?
The radius?
Yeah. So we have to have a radius to define a circle, right? Because if I have this circle versus this circle, what's the difference between them? The radius is bigger on the blue one than the purple one. So it's got to have a radius defined, okay? But also, what's the difference between a circle here and a circle here? Let's say they're the same size. What's the difference now? No, I said they're the same size. I mean, I can't draw it perfectly, but let's say they're the same size, but there's something different about them. What is it? Yeah, the center is in the third quadrant versus the first quadrant, right? Right? Okay, so the center is different. How could I make this circle be that circle? If they're the same size, let's just assume, let's say they both have a radius of 2. How could I make this circle become that circle?
Can you multiply by like a negative 1 to make it positive?
Yeah, I mean, somehow move it over there, right? Is all I'm asking. So do you see how, like with the line, we needed slope and y-intercept, parabola, we needed x squared and a y-intercept, and some other stuff that we didn't talk about. For circles, we need to know how big is the radius, because that keeps it the same size, and we need to know where in here it is. Okay? So when we write the equation, you should expect to see both of those things. Now, here's the weird thing about circles. Line started off y equals. Parabola started off y equals. Circles don't. It's definitely a difference from what algebra you guys have studied. Here's the equation of a circle. X minus h squared plus y minus k squared equals r squared. So lots of circles, or lots of squared, excuse me. So take a second to write that down. All right. I want you to just remind, we just wrote it, but we're going to put it here too so it's connected with the equation. Where is the center of this circle? It's at HK, okay? Now what gets weird is the sign. So we're going to have to make sure we're being careful. But let's take a little break, and we don't necessarily need to redraw the same picture, so just maybe put an arrow. It's okay, we're not going to fill that one out. Take a break. So here's an example of how we'll use the equation. It says, what are the radius and center of the circle with this equation? You know what? Let's put this into your notes as an example. So I will grab a copy of this, and you can flip to the example section. Remember, if you ever need more note paper, we can always get you that. Why does this look weird? Okay, go ahead and stick that in there. A little bit smaller. So, if you're given a question like this, I would recommend writing the equation, the let's call it general equation, under the given. Here's what I mean. X minus h squared plus y minus k squared equals r squared. So go ahead and copy that. Okay, so maybe I should say what I said exactly, like make it line up. So exactly lined up. Okay? The reason why is because now we can see what h, k, and r squared are. You see what I'm talking about? So center is at what again? What letter? At HK. Okay? So the center for this one is at H. What is H? H is 2. What is K?
-3.
Nope, just 3.
Oh.
So the center is where?
2 and
2,
3.
3. Okay? So now we know where we could go graph this, or at least put the center point. If it helps, you could do something like circle H and K. Alright, now for the radius, if I circle, is that the radius? Is 25 the radius? Oh, what is 25? What is it matching up to? In our general form equation, it is not matching up to r, but what? No? What does that say right there? R squared, not r. We want r. No, r squared is not the diameter. R times 2 is. Okay? So maybe arrow this down here. R squared is 25. The problem doesn't ask for r squared, it wants r. So how do you get that? Huh? It's square root, right? So square root. That's not a small thing. Like, you have to be careful. Make sure you understand why we're square rooting. So our radius is actually 5, not 25. Does everybody follow? It's just like if I asked you, well, let me let you write, and then I'll show you what I was about to say. Bless you. I want you to please put your pencil down and listen to me. If I gave you this equation, and I said, instead of where's the center and what's the radius, if I said what's the slope and what's the y-intercept, well, you could do the same thing. So write the general form right beneath the given one, and then circle the pieces. So what's the slope? 3. What's the y-intercept? 5. We're doing the exact same thing. It's just with a new equation, okay? Now, this can be a little bit tricky. Do you want to put... Let's put another one in there, actually, instead of on a blank screen. So I'm going to fit it here in the bottom of the box. Actually, before we write it, here's what we're going to look at. So put a warning. Be careful with sign of HK. So I don't want you to get mixed up. This is a different problem. Okay, so let's do an example of this warning. Let's say our equation is this instead. X plus 4 squared plus y plus 10 squared equals 30. Everybody get that written down? Okay, so we wrote up there to write the general thing underneath, so go ahead and do that. So this is supposed to line up with x minus h squared plus y minus k squared equals r squared. But what do you see is different? It says plus, not minus. So what is h? Negative 4. What's k? Negative 10, right? So it's the opposite of what you see. If it says plus 4, it's actually negative 4. Up here it said minus 2, and it was actually positive 2. Okay? So if we wrote this out, it really should be this. X minus negative 4 squared plus y minus negative 10 squared equals 30. Okay, so it's actually negative 4, negative 10. It's the opposite of what you see. Because our form requires that it says minus. That's why it's opposite. Anyway, so center for this example is at negative 4, negative 10. What's the radius?
It's 15.
Did you say 50? Oh, no, you said,
15.
yeah, but that's,
Oh,
no.
no, that's.
I don't want a decimal. I don't want a decimal. Just tell me the exact version. You did it right to get that number. I just don't want you to say that number. How did you get that?
Square root of 30.
It's the square root of 30, right? That's the radius. Why is it square root? Why don't we just divide by 2?
Trying to undo the square.
We're trying to undo squared. To undo squared, we have to square root, not divide by 2. Okay? I guess we could summarize this by saying this. Opposite of what you see. Other than that, this is, I mean, I think once you get the hang of it, you can just read stuff off really fast. Like I could give you an equation, you can just tell me center and radius immediately. Do you feel like you could do that? Let's try one. You don't need to write it, you can just practice. You'll get more practice on paper too, but let's try this on here. Okay? So let's say we have x plus 3 squared plus y minus 4 squared equals 20. Don't shout it out, raise your hand when you can tell me these two things. And it should be pretty fast. Good job, guys. Okay, keep raising them. Good. Okay. Where's the center? Opposite of positive 3, opposite of negative 4, right? Is how we're seeing it.
Yeah.
Radius, square root of 20, which is 4 point something, okay? All right. So now, here's the cool thing. From that equation, we know where to put it. Negative 3, 1, 2, 3, positive 4. So our center is here. Our radius is roughly 4. So from 4, it would reach almost down, but a little bit past the x-axis, right? Like down here. Okay? So we could, you're not going to graph a perfect circle unless you have a compass, but it's going to be roughly there. Make sense? Okay. Here's another way that we can use this. Here's a circle. What's the equation? So now we're going backwards. Okay? Let's put this one in your notes for an example. And I know you won't be able to graph it perfectly, that's fine. Let me get it sized here and then you can start drawing it. Okay, there you go. The big important things are this. You need to put the center on 3, 0, and then some random point is, there's more than this point that we could use, but that one is specifically called out. So put that point on there, which is at 1, negative 2. So first we need 2 points. 1, the center. So we're going to identify the center. Coordinates. And we just need 1 point on the circle. So what are the coordinates of the center of this one? You guys probably already wrote it, but what are they? 3, 0. Okay, so that's the center at 3, 0. What are the coordinates? They put a point here for us, but we could have used this one. We could have used that one or that one. Any of those 4. So we'll just pick one. This one, what are the coordinates of that? So 1, negative 2. Remember, it's always x, then y, so over and then up and down. Okay? All right, step 2. Write the general form equation with h and k plugged in. What are h and k? 3 and 0, yeah. Okay, so it's h, k. It's always the center. Okay, so that step looks like this. We know it's x minus h squared plus y minus k squared equals r squared. So this is going to look like x minus 3 squared plus y minus 0 squared equals r squared. That's as far as we are at this point. We know h and k, so plug those in. Okay. I'm just going to underline those, like that's the new part that we added to the equation. How do we find r squared? That's all we need, right? As long as we have r squared, we have the equation for this circle. Well, r squared is the radius, so go ahead and draw that in. I'm going to put it on the other side, I guess. There we go. So step 3 is to find, we don't really care about radius in this case. We just really want r squared. Because the equation doesn't demand that we know what the radius is, but the radius squared. So that saves us a little work. Okay? Well, you can use the idea of distance formula. So distance between the 2 points. So how do we find that distance? How do we find distance between 2 points?
Would it be like r squared equals 3 plus 1, like close parentheses, squared plus, or like
Yeah, it's minus, but
minus,
yeah.
0 and negative 2.
Yeah. In fact, let's put this formula right here. You'll have to make sure it gets on your note card. So it's this. It's what he just said, basically. So it's x minus k, no, sorry, x minus h squared plus y minus k squared. I'm going to box that. Where'd the square root go? Just a little bit ago we wrote this with the square root on it. How come it's not on there? Just reminding you, just a minute ago we wrote this. So why is that one square rooted? This one's not. It's the same thing, but what are we solving for in this case? R squared. Do we need a square root if we don't care about the r? Right? So the only reason we had the square root is if we wanted the radius. But in this, we just need r squared because that's what the formula needs. So don't square root. Okay, so let's go do that. R squared equals. Well, you could, I'm going to tell you this, but it's hard to write. So just look here. Guys, all we're doing is a Pythagorean theorem on this triangle right here. So how long is this side? It's 2. How long is that side? Also 2, right? So it's 2 squared plus 2 squared. What's 2 squared plus 2 squared? It's 8, okay? That's what we're doing. So you're welcome, if you have a graph, you're welcome to just count the boxes and square them. But just so you have an example of how you would do this if you don't have boxes, it would be what Chiron said. So let's do it this way. 1 minus 3 squared. That is x minus h squared. Plus negative 2, so y minus k, which is 0 squared. Everybody see what we just wrote? Like where it came from? X minus h, y minus k. And then square both. R squared equals, what is 1 minus 3? Negative 2. What is negative 2 minus 0? Negative 2. Okay, so this is 8, just like we thought it would be. Negative 2, let me write it one more line, I guess, just so we don't get confused. Okay. Again, you could just look at the graph. and say, hey, that's 2, so there's 2 squared. That's 2, so that's 2 squared. 4 plus 4 is 8. Do it with the graph, it's faster. Okay? In fact, let me just put that, or use the graph. Alright, last step. Well, of course we need to write this equation with everything plugged in. Let's just put it this way. Fill in r squared, does not look like an r, to the equation. So our final is going to be x minus 3 squared plus y minus 0 squared equals 8. That's the equation of that circle right there. Pretty cool, right? You could be given some random circle, but you can write the equation for it. Now you have the definition of every point on that circle. Alright, why don't you try this other one by yourselves? We did the top one, or the bottom one, so go ahead and do the top one. So we already have the points identified, that was given. I would go under here and say this is HK, because it's the center. And we need to write our general form. It's kind of our roadmap. Okay, what goes in for H? So x minus -1. And it's okay to write it with both. You should, in fact. Alright, what goes in for K? Two. That's too big. 2 squared. Alright. So it's okay to leave this as x minus negative, but really what is minus negative? It's plus. So if you want to clean it up a little, you could rewrite it as +1. Alright, now we need to find r. How do we do that? Okay, I'm going to tell you, you guys don't have this printed on your paper, but you can see it. So we can just do these 2 lengths, right? You can fill in the formula, that's totally fine. But you could also just do this. So how long is this side? Like pick a point and just go down. How long is that? It's 3, right? From that point, 1, 2, 3 to the bottom. And how long is this side? From here to there, it's 2. So it's 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4. So it's 13. Okay? If you want to write it all out, here's how that would look. So let's start with 1 minus -1 and 2 minus 5. 1 minus -1 is 2, so 2 minus 3 is -3, or 2 minus 5, I mean. And then this just is 13, okay? But you could have just done 3 squared plus 2 squared equals 13. Either one. Do you see why the graph is kind of nice and quick? Okay. But either way, we end up back here at x plus 1 squared plus y minus 2 squared equals 13. So that's the equation of that circle. What's the radius? It didn't ask for that, but what is the radius? Don't tell me a decimal. Square root of 13. Yeah. Since we know r squared, we just square it. Sorry, we just square root it. Cool. How'd that go for you? Good? Overall? How'd that go for you? Yeah, okay. Well, we'll get better at it. Let's see. We'll try that one probably tomorrow. Not gonna do those. Alright, last one and then we'll stop. Well, I'm gonna hand you a sheet. How do we graph? We kind of talked about this, but how do we graph a circle? It's not gonna be perfect. I will start by saying that. What do you think? Here's the equation for it, so we know two things for sure. Which are what?
Center.
Alright, everybody? Actually, don't shout it out, but just give you 10 seconds to think about what the center is, and then I'll tell you. Okay, what was it?
-3, 4.
Nope.
I'll say 3,
3, negative 4. It's the opposite of what you see, right? So opposite of negative 3, opposite of 4. So 3, negative 4. So we just go plug that in here. Negative 3, so 3 to the left, and then down 4 is right there. That's our center. Alright, what else do we need in order to draw a circle? We need the radius. We need to know how far from the center all the points are. So how far is this, or what is this radius? That's r squared. Right? So this is h, k, and this is r squared. This time we actually need the radius. It's 3, right? So the square root of 9, which is 3. Okay, so here's what we know. We know that from this point, all the points are 3 away, 3 units. But I only can count that in the horizontal or vertical direction. Does that make sense? So 1, 2, 3, there's a point there. 1, 2, 3, there's a point there. 1, 2, 3, there's a point. And 1, 2, 3, there's a point. Those are the only ones we know for sure where to put them. Now, if you don't have a compass, you just do your best to fill in the circle around those points. If you do have a compass, how would you use it? So here's our compass.
Find up the letter pin at the middle, and then
Okay?
set the pencil to the 3 points out,
Good.
and then hold the left pin down and just trace around it.
Okay, so this tool is not very user friendly, but yeah, you did good. Alright, so that looks about right. Scoot it in maybe just a little. So there's your set distance, right? And then now we can just go ahead and draw that circle in. Okay, so that's the circle for that specific equation. Find the center and the radius, that's all. Not too bad.